Okay, good afternoon, students. So this is the second discussion or the second part of the stereoisomers or chapter 2. So for this discussion, we will be having the topics enantiomers, racemic mixtures, mesocompounds, and diastereomers. Okay, so let's start. So I will be presenting you the word version of this lesson because para pareho tayo ng material, ng study material na nakikita. Okay, let's start. You have enantiomers. Okay, if we look at the structure of lactic acid molecules, CH3, CHOH, and COOH. So, when seeing the chemical formula, you will already locate the chiral carbon. So, how to locate the chiral carbon again? Bilangin muna ilan ang carbon atoms that are present. So, you have 1, 2, and 3 carbon atom. So, in the first carbon atom, tatlong H or hydrogen group ang nakadikit. So, it is not a chiral carbon atom. Last group naman, you have 2 the same oxygen na nakadikit sa kanya or bonded with your carbon atom. So, your number 3 carbon is not a chiral carbon atom. The second one is the chiral carbon atom because it has 4 different functional groups that are bonded in it. So, you have the hydrogen, you have the methane, CH3, and then you have the OH, hydroxide, and lastly, the carboxylic group, COOH. So, the chiral carbon atom is the second carbon atom. Okay, so that is a formula for the lactic acid molecule. So, it has 1 chiral carbon atom. That means it has 4 different attached atoms to it. Chiral molecules that are mirror images of each other are stereoisomers. Again, yung chiral molecules ninyo that are mirror images of each other. Okay, correct? So, stereoisomers sila that are mirror images of each other. You call those as enantiomers. Again, enantiomers, they are stereoisomers that are mirror images of each other. Just like here in your lactic acid. Okay, so mirror images sila. You have the negative lactic acid and the positive lactic acid. Okay, so this is the levorotatory isomer and this is the dextrorotatory isomer. Dextrorotatory because it has the positive sign and levorotatory because it has the negative sign. Okay, one that rotates the plane polarized light to the right is dextrorotatory with a positive sign. And one that rotates the plane polarized light to the left is levorotatory with the negative sign. So, meaning the negative form of the lactic acid rotates the plane polarized light towards counterclockwise or to the left, while your lactic acid or your dextrorotatory form of the lactic acid rotates the plane polarized light towards the right, okay, or clockwise. So, these two are stereoisomers. Why? Because they have the ability to rotate the plane polarized light, but only in different directions, towards the left and towards the right, negative and positive. Okay, so they are both enantiomers. Why? Stereoisomers sila that are mirror images of each other. When you say mirror images, one example natin dyan is yung ating hands. Okay, so hands, mirror images. Kuha. So, di ba, your OH is located in here, sa kabila, mirror image niya. So, dito nasa right ang OH, dito nasa left ang OH. Ang H is nasa left. Hydrogen on the other side is on the right. So, mirror image siya. So, meaning two stereoisomers that are mirror images of each other are called enantiomers. Okay, so tapos na tayo dito. The minus sign indicates that the rotation is to the left or counterclockwise. And the plus sign, positive, means the rotation is to the right or counterclockwise. So, Again, when the mirror images are not superimposable, it means that it is a chiral substance. So meaning stereoisomers sila. Why? Because the mirror images are not superimposable. If you place the positive lactic acid on top of the negative lactic acid, they will not coincide perfectly. Why? Because OH ang nasa left dito, while on the other side, the H ang nasa left side. Kuha? So, may difference. Okay, so many molecules that contain a chiral carbon are chiral but not all. So, tandaan, not all molecules that contain a chiral carbon are chiral. So, hindi mostly lang, no? Most of the molecules na merong chiral carbon is chiral, pero hindi lahat. So, paano mo malalaman if chiral carbon siya? Okay, so how will you know if it is a chiral carbon or it is a chiral molecule? So, to decide whether a molecule is chiral and has an enantiomer, draw the structure of the molecule with its mirror image and see if they are superimposable. Okay, so the first step is to draw the mirror image. So if you have a sample or a sample molecule, to find out whether the molecule is chiral or not, the first step in finding out is to first draw its mirror image. And then after drawing its mirror image, see if the mirror images, the left and the right, are superimposable or not. If they are superimposable, then meaning the molecule is a chiral with a chiral. And then if the mirror images are not superimposable, then meaning that molecule is chiral. However, the first consideration is to find if there is a chiral carbon. So, kailangan malocate mo muna yung chiral carbon doon sa sample. Siyempre, if there is no presence of chiral carbon, then understood na it is not chiral molecule. Or not, because not all chiral molecules contain carbon. Pero yun yung first step natin. First, locate sa sample kung nasaan ang chiral carbon. So, for example, we have two compounds. You have the 2-chlorobutane and the 2-propanol. Okay, so you have here 2-chlorobutane. So, why 2-chlorobutane? Because your chlorine atom is located on the second carbon. Kita? So, by the way, where will you start counting? Again, so ang number 1 na chiral carbon, ang number 1 na carbon atom, dito kasi diba you have 4 carbon atoms. 1, 2, 3, 4. So, paano malaman kung nasaan ang 1 carbon? Ito bang left or itong right? To know, you will base kung saan nakadikit yung first functional group. Okay? Kung saan nakadikit, saan pinakamalapit sa pinakaunang carbon nakadikit yung functional group, then meaning doon ang first carbon. For example, dito, basing from the left side, 1, 2, 3. So, pangatlong carbon pa bago makita, or sa pangatlong carbon, when you start counting from the left side, pangatlong carbon pa nakadikit ang chlorine. On the other hand, if you start on the left or the right, on the right side, then 1, 2. So, sa pangalawang carbon dito. So, meaning, dito ka mag-base ng number 1 carbon. Kuha. This is the number 1 carbon because it is the carbon in which nearest yung nakadikit na functional group. Okay? So, 1, 2, 3, and 4. So, 1, 2. So, 2-chlorobutane. Okay. So, if we look at the structure in the formula number 3, balikan natin yun. Kanina. So, i-check mo muna, no, kung check first if the when you turn the mirror image 180 degree, kung magkakaroon ba siya ng magko-coincide ba siya with structure number 1. So, dito, hindi siya magko-coincide. So, enantiomer ang 1 and 2. On the other hand, your structures 3 and 4, kapag nirotate mo ang structure for ang mirror image to 180, then ang resulting structure will be the same with structure number 3. So, meaning these two are the same compound. Kuha? So, same sila na compound and you call them as mesocompounds. Mesocompound sila. Okay, bakit mesocompound? If we look at the structure of formula number 3, there is an internal plane of symmetry in the structure. So, between your carbon number 2 and carbon number 3. Carbon number 2, carbon number 3. So, kapag hinati mo sa gitna, paano mo ma-check if mesocompound siya? Kapag hinati mo sa gitna, symmetrical ang top part sa bottom part. So, meron siyang plane of symmetry. If there is a presence of plane of symmetry, then that means the structure is meso, or the compound is mesocompound. Meaning, pareho lang. Pareho lang ang structure number 3 and 4. It is the same compound. It is a mesocompound. Okay. Definition, you have stereoisomers that contain chiral carbon atom and are superimposable on their own mirror images. So, mesocompound or meso structures. So, the rotation of polarized light in one direction by half of the molecule is exactly compensated by an opposite rotation of the other half. So, all mesocompounds are optically inactive. Inactive ang inyong mesocompounds. Okay. So, it was Pasteur who first used the term meso to name the kind of tartaric acid that was optically inactive and could not be separated into different forms by any means. So, Pasteur called it as mesotartaric acid because it was intermediated between positive and negative tartaric. So, your mesocompounds, partly positive and partly negative sila. Kaya hindi sila ma-separate. They will not be separated. So, doon sa example kanina, you have one pair of enantiomer. You have negative tartaric acid and positive tartaric acid and one mesocompound because your structure number 3 and 4 are the same. It is the same compound. Physical properties of tartaric acid stereoisomers are shown in table 2. The specific gravity melting point and solubility and specific rotation of your positive and negative tartaric acid are the same. So, magkakapareho. So, tingnan dito. Okay, so tartaric acid, pareho lang ang values nila for specific gravity, for melting point, and solubility. Same lang. Nagkakaiba lang sila sa specific rotation because the positive has a positive 12 value or degree while sa tartaric negative 12 degree because they differ in the direction of rotation. Now, the racemic However, mesotartaric acid has totally different physical properties compared to the enantiomers. It has lower specific gravity, melting point, solubility, and no optical rotation. So, tingnan natin. Tama. So, mas mababa ang kanyang specific gravity. Mababa rin ang kanyang melting point and ang kanyang solubility ay hindi pareho doon sa sample natin na enantiomers. And also, since your meso compounds are optically inactive, so 0 degrees. Wala silang degree of rotation. On the other hand, racemic mixtures has the higher melting point than either of the two enantiomers. The melting point of the substance is largely dependent on the attractive forces holding the ions or molecules together. So, anong indication nun? Ang iyong racemic mixture is, tandaan, racemic mixture positive and negative siya. Siya may pinakamataas na melting point, and it says that the basis of the melting point is to the presence of positive and negative, or the interaction between your attractive forces, positive and negative. So that means, kaya mas malaki yung melting point ng inyong racemic mixtures is because it has to do with the attractive forces of the positive and negative. So, ang attraction ng positive and negative, mas malaki sa attraction between positive, positive, and negative, negative. Kasi nga, ang positive tartaric acid natin only contains positive forms, and ganun din sa negative. So, mas malaki ang attractive forces ng positive and negative. That's why, mas malaki din ang melting point ng inyong racemic mixture ng tartaric acid. Okay, sample. Consider following examples. You have sample number 1 and number 2. So, ang tanong, how many stereoisomers can exist? And letter B, write their structure, label any pairs of enantiomers and mesocompounds. And letter C, point out if there are any diastereomers. Okay. So, sample natin yan siya. So, number 1 sample, there are 2 chiral carbon atoms. Meaning, substitute, so meron siyang 4 na possible na stereoisomers. So, draw first the 2 original structures. You have the structure 1 and structure 3. So, dito, ang number 1 niya, opposite muna ang hydrogen, while sa second original structure, parallel ang hydrogen atoms and ang Cl. Okay? So, after madraw mo yung dalawa, sunod mo naman ang mirror images nila. So, draw the mirror images by drawing. After drawing the mirror images, rotate the mirror image and try to look if they will coincide with the original structures. So, dito kapag na-rotate ito sa taas ng ethane, sa baba ang methane, which means hindi siya mag-coincide with your original. So, the pair number 1 and pair number 2 are enantiomers. Next, structure number 4, when you rotate it, the ethane group will go to the top and the methane go sa baba. So, hindi rin siya coinciding with your structure number 3. Meaning, these pair are also enantiomers. So, walang 0. 0 ang mesocompounds. And then, you have 2 pairs of enantiomers. What? Then, ano pa ang kailangan? Ilang diastereomers. So, sabi is mas maraming if there are more presence of enantiomers, then tataas din. Your diastereomers, the number of diastereomers will also increase. So, dito meron tayong 2 pairs of enantiomers, meaning merong 4 na pair ng diastereomers. So, ano yun? 1 and 3, 1 and 4, 2 and 3, and 2 and 4. Okay? So, the diastereomers, yun na, nabigay na. So, ilang stereoisomers? 4. 2 to the power of 2 for stereoisomers. And then, 2 pairs of enantiomers. You have the 1 and 2 pairs of enantiomers, 1 and 2, and 3 and 4. And then, you have 0 mesocompound. And then, you have 4 pairs of diastereomers. So, ganyan ang pag-answer ha when it comes to exam and your quiz. Ibigay ang numbers and ano yung pairs. O ha? So, 4 stereoisomers, structure 1, 2, 3, and 4. 2 pairs of enantiomers, pair 1 and 2, and pair 3 and 4. And then, 0 mesocompound, And then you have 4 pairs of diastereomers, 1, 3, 1, 4, 2, 3, and 2, 4. So, ganyan ang pag-answer natin. So, second example, you have, there are 2 chiral carbon atoms. So, possible din na number of stereoisomers is 4. So, first answer yan. So, draw the 2 original structures and then isunod ang mirror images. So, now, if the structure number 2 i-rotate mo into 180 degree, hindi siya magko-coincide with structure number 1, so it is a pair of enantiomers. On the other hand, your structure number 3 and 4, kapag ni-rotate mo ang structure number 4 into 180 degree, ano ang resulta? It will exactly coincide with structure number 3. So, meaning this is the same compound and it is a mesocompound because it has a plane of symmetry. Pareho ang between your carbon number 2 and carbon number 3. So, pareho ang top and bottom kapag hinati sa gitna. So, mesocompound ito. So, ilan ang possible stereoisomer number? 4. 4 na stereoisomers. And then, ilan ang pair of enantiomers? 1. There is 1 pair of enantiomer. You have pair 1 and 2. Ilan ang mesocompound? You have 1 mesocompound. Your number or your structure number 3. 1 mesocompound. Structure number 3. Kasi ito mirror image nilang man yan. So, your mesocompound is the structure number 3. And then, you have 2 pairs lang ng dalawang pair lang ng diastereomers. Kasi nga, isang pair lang man ng enantiomer. So, times 2 kasi ang diastereomers natin. So, if 2 pairs of enantiomers, 4 ang diastereomers. If 1 lang ang pair ng enantiomer, then 2 lang ang diastereomers. So, meron din cases ha na meron kang tatlo. Meron kang tatlong pair ng enantiomers. So, mangyayari dyan, meron kang 3 chiral carbon atoms. Dito kasi dalawa lang. Merong instances na tatlo. So, meaning 6 na structures ang idodrawing mo. 3 original structure and 3 mirror images. So, 6 na structure. So, meaning kapag may 6 na pairs na enantiomers, there are 6 pairs of diastereomers. So, for dito, isang pair lang man. So, you have 2 pairs of diastereomers. First pair is 1 and 3. And the second pair is 2 and 3. Hindi mo na isali ang structure number 4. Why? Because it is the same compound with number 3. Pareho lang siya. So, itong tatlo lang i-base mo. 1 and 3 and 2 and 3. Yan ang number ng iyong diastereomers. So, ganun ang pag-answer. State kung ilang number ang stereoisomer, pair of enantiomer, mesocompound, and diastereomers. And then, isali mo rin kung ano yung pairs na yun. Structure 1 and 2, structure 1 and... Okay, kuha. Okay, further reading. The shape of our senses. Mirror image recognition depends on sensing whether groups are on one side or the other side of a fixed reference. For example, if our hands are palms down on the table, the right hand has the thumb on the left while the left hand has the thumb on the right. And we can see the difference. So, living systems differentiate enantiomers in the same way. For example, the enantiomer of amino acid asparagine bind to human taste buds differently. As shown below, the 2 molecules have a mirror image arrangement and bind with groups on opposite side. So, no matter how these molecules rotate, they can never be superimposed. So, we recognize the asparagine as sweet, while your S asparagine is tasteless. So, one more important commercial product is the artificial sweetener aspartame. So, you have the NLA aspartyl and L-phenylalanine. Has a very sweet taste while its enantiomer NDA aspartyl L-phenylalanine is bitter. So sa ating ginagamit siya or your senses, for example, the taste dito, it will matter based on the type of isomer present, either for left and right. So, yung D natin, asparagine, is sweet siya, while the other one is bitter. Okay? So, the human nose is even more discriminating sensor, no? Compared doon sa taste. With eyes closed, a person can sniff the difference between an orange, positive limonene, and a lemon, negative limonene. So, kita nyo, biological processes ito sila. So, very specific ang biological processes, like sa ilong natin. So, magkaiba, ma-identify ng ilong mo ang amoy ng orange from a lemon. Why? Because the smell of the lemon being positive is sweeter than the smell of the orange is sweeter than the smell of the lemon. So, positive and negative siya. So, sometimes only one enantiomer produces an aroma. Okay? So, pwede rin isang type ng enantiomer lang or isang isomer lang doon sa enantiomer ang mag-produce ng aroma. So, the smell of jasmine is recognizable when the molecule is at a concentration of 0.03 ppm and while its enantiomer has no odor. So, other times, one enantiomer produces a much stronger odor than the other. So, the musk aroma, warm, sensual, natural, used in perfumes comes from, so may musk pala na aroma. Using perfumes comes from an isomer that can be smelled in concentrations as low as 0.6 ppm. Enantiomer is only detectable at 0.2 ppm. So, nagbe-base din sa concentration nila, no, kung ma-smell ba sila ng nose or hindi. Pero, magkaiba sila na isomers, magkaiba din ang level ng concentration kung saan pwede silang maamoy. Just like your musk aroma. What is apparent for taste and smell holds throughout all biochemistry. Hormones and neurotransmitters are recognized by shape. Metabolism only works on molecule or of the right shapes. A mirror image difference is in shape can change everything. Okay, so tandaan ang stereospecificity or stereospecific reactions. So, your biological processes holds stereospecificity, meaning specific lang sila for a certain type of isomer, either positive or negative. Okay, so that sums up the lesson for our second part of stereoisomers. I hope na meron kayong natutunan. And if you have further questions, just send me a comment or a DM. So, I hope na mag-DM kayo. Wag naman masyadong gabi, no? Like 10 p.m. like that. So, please DM me at working hours lang. Okay, kasi si ma'am, meron din siyang other activities outside school. So, please, kapag merong mga questions, try to send your questions at working hours or at daylight. So, gagawin ko rin yan sa inyo. So, hindi ko kayo, I will not be sending you starting from now, announcements, no? Kapag lampas na ng 7 p.m. So, at least 6 p.m. Pwede pa yan, mga 6 p.m. You can message me. Okay, that's all. So, thank you everyone and see you on my next discussion.